what is left for us for the revision, Anna? And I think I was using this file, Chandra SP105. And yes, we revise combination of mirrors, reflection. Are we done with reflection, guys?
Yes, sir.
We were done with reflection, I believe. Yeah. 1 second.
Yes, sir. We started spherical mirrors too.
Right. Let's start then. Spherical mirrors. Reflection. Yeah, I remember we have done some questions also. I know. Now let's continue with lateral magnification. This is also known as transversal magnification. Very easy peasy thing. What kind of magnification is this? See guys, if I tell you that we have a concave mirror, it forms the image of an object which is just two times of the size of the object. Then what do we say? What is the magnification?
2.
Exactly.
Magnitude is 2.
You have shared with me the question paper, I believe, right? Shashir, did you share with me the question paper?
Me?
Some from mock test. I am not aware of mock test, but if you guys had, someone is asking, can you discuss the 16th question from yesterday's science mock test? I just wanted to know if the answer B, E, or C is correct. So can you share with me that question here? I'll just be waiting for you. Once I get that, I'll discuss. Now,
Yes.
till then, we come back here, magnification definition. Okay, guys, one more question. If the size of image is 3 times as the size of the object, but the image is inverted, then what would you say about the magnification?
-3.
Exactly. So everyone knows, sir, magnification can be positive, can be negative. Positive magnification means erect image. Negative
virtual.
Positive magnification, erect and
Virtual.
yes. Keep in mind, erect images are always virtual, and inverted images are always real. So we can figure out many things just by knowing the magnification. Okay, just a second. I think Shubh has shared with me that question, and let me download that.
So most of the questions are in image file, so can't type.
Most of the questions are Shubh?
In image file.
Okay, not a problem यार, तो सारी image ही रहती है. Just a second, Shubh, just a second.
Sure.
Mubashir also share the question. Guys, one by one, okay? Just hold on, one by one. 16th question, what was the 16th question? 16th question, yes, 16 was, an object is kept in front of a focal length of mirror. The possible distance of the object from the mirror is, okay. So I'll discuss the 16th number, not a problem. I'll put it so that we all can understand what's going on, okay? So side by side, first of all, let me just complete this magnification part, okay? So by definition, magnification is very simply defined as the ratio of the height of the image to the height of the object. And this definition of magnification is general, bacha, general. Do you understand when I say general means this magnification definition is hold good for mirror, hold good for lens. It is good for image formation by a spherical surface, image formation by the curved surface, image formation by refraction, reflection. Anyway, this is the general definition of magnification, which is equal to the height of the image to the height of the object. Is that clear?
Yes, sir.
We'll do that after the class. Support team. Okay, fine. Bacha, hold it for the time being. I'll discuss every question because I just want to finish this. Yes, Prakshit, just hold on for a few minutes, okay? I'm coming one by one there. So let me just complete this part. Magnification is the ratio, so it has no unit, you know, meter cancel out. Negative magnification means image is inverted, and what is the other thing? Image inverted and real. Erect and virtual?
Yeah.
Yeah, give me a second. Okay, fine. So now coming to the question which has been asked, it will be a revision for every one of you. Let me just put it. Read the question. An object is kept in front of a concave mirror of focal length 20 centimeters. So focal length is minus 20 centimeter. Why I'm taking minus? I think every one of you can understand. Yes, concave mirror. The image is 3 times the size of the object. Oh, cool. Image is 3 times, image height is 3 times as the height of the object. That's really cool. Yes, the possible distance of the object. Acha, listen, concave mirror forms 20 centimeter. The image is 3 times as the object, the possible distances of the object from the mirror. Listen carefully. Concave mirror forms magnified image in 2 cases. When the image is real and inverted, when the image is virtual and direct. Agree or not?
Yes, sir.
Yeah, it's a concave mirror, so you have to consider both cases. Did you remember I asked you guys? Okay, listen carefully. Height of image by height of object is equal to V by U or minus V by U in case of mirror?
Minus V by U.
Minus V by U. Yes. And do you remember I asked you to memorize directly V is equal to UF by U minus F? Do you all remember?
Yes, sir.
Yes, sir. So I just plug this V here and then see what is being cancelled here and what you are left with. U and U cancel here. What you get is F by F minus U because this minus is taken. So U minus F becomes F minus U. This is magnification. Very easy to solve this question if you know my trick. So now we will take both case when image is real. Image is real. Obviously, if it is real, then it is inverted, right? So what will you take magnification? +3 -3 quickly.
-3.
-3. We are going to plug in this tricky formula, guys. -3, F is equal to -2, -20, sorry. F is equal to -20. Look, this F. And this F is again -20. We don't know the object distance. Just solve it and get it. -3 -20 plus 60, exactly, +60. And then +3U is equal to -20. So when we take this 60 this side, it becomes -80. So U is equal to -80 by 3. How much is it approximately, guys? -3 2s are 6. 3 6
You don't need to do that. The options are in fractions itself.
Focus on center of curvature.
So this is -80 by 3. One option is this correct, guys. This option is correct. Option 1. Now check case second when image is virtual and direct. What is magnification?
+3.
Yes. So let's plug that quickly. Magnification +3. Focal length -20. Focal length -20 minus U. So it becomes -60 minus 3U is equal to -20. So U comes equal to -20 plus 60 is +40. So it is -40 by 3. -40 by 3 is also the answer. So 2 options are possible here. 2 possibilities are there. Because it just says that the image is 3 times. It is not saying whether image is real or virtual. So we need to consider both cases. I hope you guys understand it. Yes?
So,
Yes, sir. But in the exam, they did not give us like the option to choose 2 options.
They must give it. Otherwise, they are making a big mistake. And this is not justified. Whosoever designed this question. Yes.
So can
So
we
we
use
can use
another
one-
method and solve this? Like,
And another method you can use, Rachit.
so
But the
like for
prob-
example,
I
one logic
understand.
we can use.
I understand. Look, I'm telling you, another method, but that is lengthy and complicated. Another
No, so you
method
can
is,
solve it mentally. Like we know that whenever
I mean,
a concave mirror,
you
yeah,
are
a concave mirror forms it only between C and F, the larger size image.
between P and F also. That's what I'm telling you.
But that is virtual, right? Here it is real. So
No,
They didn't
where it is
specify
said,
that.
where it is said it is real. It doesn't say that, right?
so the magnification is -3, so it will always
No,
be real.
where it says magnification is -3.
So we took magnification -3.
Yeah,
It doesn't say magnification is -3. It says image is 3 times of the object. And question is good. There is nothing wrong with the question. Why? Possible distances. This is the hint that you need to consider both. So whosoever designed the question, they design it wrongly. Otherwise, the statement is completely perfect. You understand? Don't destroy your concept only because you see the option is not matching. Your concept is exactly clear. You guys are right because we know when we keep object in between C and F like this, we get image like this 3 times. And when we keep the object between P and F, we get image 3 times this side. So there are 2 possibilities. Yeah, Shubh, tell me.
No, sir, got it.
Do you guys understand? Your concept is clear, bacha, and keep it clear only. Don't go away from your concept, okay? Just to satisfy the author, he is making the mistake, you guys are not. Don't do that. Fine?
Sir,
Yes, sir.
Yeah, tell me.
The second question also.
Okay, 1 second, let me check that. Yeah, you guys have shared so many questions. Sir, formula is v is equal to uf. No, v is equal to uf by u minus f. I have written here, check it please. Please check it faster, bache. V is this, magnification is this. Okay, now moving on. One more question was asked. Let me quickly look that. Is it Mubashir?
Yes, sir.
Okay, after that Prakshit, I think. Yes. Parikshit after that. Okay, let me see what question is this. Okay. This is assertion and reason question, right?
Yes, sir.
Okay, fine. That's good. Look at the question now, guys. Look at assertion. What it says, the refractive index of diamond is √3. √6 is approximately how much, bacha?
2.5.
2.42 something. Yeah, it is 2.42. So this is correct. Diamond has this much refractive index, 2.42. √6 is 2.42. Refractive index of liquid is √3. Fine, because √3 is 1.44 approximately. 1.3 √3 is
1.7.
1.734.
okay.
0.732.
That's fine. It says √3, just take it √3, not a problem. It's okay, fine. Liquid may be different liquid, not water. You understand? So it may be √3, not a problem, because it's not especially mentioned that it is water. So √3 possible. If the light travels, the important point is if the light travels from diamond, that means denser to the liquid, that means denser to rarer, it will be initially reflected when the angle of incidence is 30 degree. It will be initially reflected. It's something missing here. I'll discuss that. Okay, don't worry about that. Internally reflected it should be when the angle of incidence is 30 degree. And the reason is refractive index is 1 by C, where you use the refractive index of diamond with respect to the liquid. Have you guys learned about total internal reflection?
Yes, sir.
Yes, sir.
Yes, sir.
What happens in general case, guys, if you have denser medium and this as rarer medium, then what happens if light hits and the angle of incidence is very low, then some portion is reflected and some portion is refracted. This is generally happens. But if angle of incidence is increased, let's say this much, then what happens? All the light is reflected internally. That means this is called total internal reflection. No light is going out. So only reflection is taking place, no loss of intensity. Here intensity is lost in here and here, maybe 50% reflection, 50% refraction, but here total internal reflection. And this takes place beyond certain angle, and this angle should be greater than critical angle. What is critical angle? Critical angle is that angle at which angle of, look, this is the critical angle, bacha. Watch, all of you, understand it. If light ray hits like this, at some particular angle, we don't know. So reflected part will come inside, but the refracted is perpendicular, 90 degree. And if you increase the angle more than this critical angle, then TIR will take place, total internal reflection. Otherwise, if your angle is less than critical angle, both reflection, refraction taking place. If angle is more than critical angle, then total internal reflection take place. If you want to find this critical angle, it's very easy for you. How? Sin theta c has formula is equal to 1 by n. N basically refractive index, and I should mention it like this because it says where the light is going from, guys. √6 refractive index, n1 is equal to √6 and n2 is equal to √3. Yes. So what is angle of refraction? 90 degree. Angle of incidence, critical angle, theta c, applying the Snell's law. n1 sine I, n1 root 6 sine I is equal to n2 sine R, n2 is root 3 sine R. Angle of refraction is 90 degree. Sine 90 is 1. I hope everybody knows that. Then sine I is equal to root 3 by root 6. How much is this, bacha? Root 3 by root 6?
1/2.
1 by root 2. Wrong.
I is 40,
1 by root 2. So what is I?
45 degree.
45
45 degree.
45 degree. That means if the light hits at an angle of incidence more than 45 degree, then TIR will take place. Otherwise not. Agreed or not?
Yes, sir.
Yes, sir.
Now what is the question saying? There is a misprinting, typo, what should I say? I don't know. But there is a perfect error in it. Angle of incidence is 45 degree. Acha, this is assertion reason question, correct? So
Yes, sir.
in this question, first of all, it's not total internal reflection is not taking place. Why? Because the critical angle is more than 90 degrees. So option A is, assertion is wrong. Agreed?
Yes, sir. Assertion is wrong.
Secondly, you can't write refractive index is equal to 1 by sine C. You must write refractive index. It's not only the other medium is not air. Understand it. This is only valid when the rarer medium is air. Refractive index is 1. But in general, we should from here, what do you write? Sine C. Tell me, guys, from here, what do you
But
write?
later on in the sentence, it's mentioned that mu is a diamond with respect to liquid.
Okay, then that's perfect. Then that's perfect. But still, the reason is correct, but reason is not. The refractive index is defined like this. That's really true. Fine. It's not a problem. But the first statement is incorrect. It's not totally internally reflected because 30 degree is not possible. Yes or no?
Yes, sir.
Yeah.
Yes. Angle is greater.
Sir, can you explain why reason is correct?
Reason is correct, but not correct explanation. Reason is we know refractive index is like this. Mu is what? Refractive index of diamond with respect to liquid. So just from here, check it now. From my method, how do you write critical angle? Sine theta C is the critical angle now. Theta C. So sine theta C is equal to how much? Check it. Sine theta C is root 3 by root 6, which is according to this, because this is relative refractive index. Sine C is equal to 1 by mu. Mu is mu2 by mu1. So this is true, but this is not the correct explanation. Reason, correct explanation, it is said initially reflected. When it should be internally reflected, then it makes sense. So I have a problem with this. It should be internal. Let me read it further. The light travels in the diamond to the liquid. It will be initially reflected. Acha, internally reflected, if it was initially reflected when angle of
Sir, it is a typo maybe.
if it is trying to say that internally reflected, then we can agree with this, because this angle is 45 degree. Before this angle, like if you take 30 degree angle of incidence, then this is called internal reflection. Even if it was mentioned in the question that it is internally reflected, then we would take the option A as the correct option. Do you understand? Internally reflected, then option A would be correct and reason would be the correct explanation. But it should be internally. So understand the difference. This is internal reflection. This is total internal reflection. No loss of intensity. But in internal reflection, there is a loss of intensity in refraction part also. But if it is total internal reflection, no loss. And it is the correct explanation also. Why? Critical angle we got 45. And angle of incidence is 30, less than critical. So internal reflection. So it should be internally reflected. So there is a typo, just ignore that. And if it is internally reflected, then assertion is true, reason is true, and reason is the correct explanation. Because from the reason, critical angle is 45 and angle of incidence from assertion is 30 degree. That's why internally reflected. Fine, guys?
Yes, sir.
Okay. Yeah, it's CBSE level only. It's confusing.
Yes, sir. It's the
because
most one.
yeah, it's actually confusing because of the word initially. It should be internally. So there is a typo. Critical angle formula, simply apply a Snell's law where you see that angle of refraction is 90 degrees. Just apply Snell's law there. Now coming to Prakshit question. 1 second. Let me download it. Just a second, bacha. Just a minute. Yeah, Prakshit had asked a question. Oh my God. Mock test. They're asking these questions. Huh? This one is really tough question. It was asked in JEE entrance examination, and you guys are 10th standard student. So they are expecting a lot from you guys, right?
Yes, sir.
Okay, now you need to pay attention if you really want to understand it. Okay, that's good. Good. Listen, the point is, you would be able to, what is the question asking? The greatest distance. I know the question, so I'm telling you. A man is walking on this line. So how much he should walk, how much distance over which he will be able to see the image of this point P in the mirror. And you know, this image will be on the same side. Okay, same distance behind. So image of the point P. It's okay, Akshit. Let's look here now. You will understand it. Everything else is given. This is D, this length is L, and total length is 2L. Now, what I'm telling you, watch it carefully. You need to pay attention. It's less physics, more geometry. Okay, watch it carefully. I have to take one ray at this extreme. Whenever this type of question comes, take one ray at the one extreme of the mirror. And you know, it is going to be internally it is going to be reflected only. So it's reflected and it's coming here. So first time the observer will see the image when the observer is here. So this is the point A. He is going up. First time when he is here, the ray is coming from the mirror, coming from the image. Look carefully. Then he would be able to see the image. That is the point. First time at this point A. You don't just want to get confused. So I'll put it a different number. Maybe let's say it's Q, right? Second, another extreme is here. Let's incident the ray there. And image is here. So if we extend it back, oh my God, it's going here. So the last time observer will see the image when he is here at R. We have to find this distance QR. Now it's geometry, it's not physics. So please understand, bacha, if you are here, no ray is coming into your eyes. So you would not be able to see the image. If you are here, no ray is coming into your eyes. You would not be able to see the image. You have to be only in this much region, bacha, in this much region. This is called field of view of image. This region, a space is called field of view of image. How to draw the field of view? From the object, take the two rays at the two ends of the mirror. Then this region or space you get, that is called field of view. So if observer is in this view, he will be able to see the image, otherwise not. That's why the first time he see the image when the observer is here at Q, and the last time when he is at R. Now we have to find this distance QR. This is the greatest distance. Now geometry, bacha, listen to me carefully. This distance already given in the question. How much is this, bacha? D. Yes. We need to find this distance, and we need to find this distance. We have to use a little bit geometry. It's easy. You guys can get it. Now I'm helping you. Just hold on. Listen to me carefully. Watch it, and I'm sure you are going to get it. Okay. Look at this. How much is this? This object is at a distance L, so this is also L. That's cool, fine, not a problem. L distance, L in front of, yes. Look at this angle. This angle, bacha, this angle. And look at this angle. Is it same? Yes or no?
Yes, sir. Yeah.
Yes. So you apply geometry a little bit only a little bit geometry. Now, one more question. Triangle similarity. So if you compare this triangle similar to this triangle, you can easily prove that this distance is actually equal to how much? if what is the P? P is set in front of the mirror with a man is walking along a point source is present vertically on a wall. A point source P is placed at a distance L in front of a wall with a distance here. Man is walking the line to the mirror to L distance, the greatest distance over which the object can see the mirror. Yes, fine. So what I'm telling you, listen to me carefully. If we can find this distance, we can find this distance. You have to just add this distance and this distance. Yes or no? Yeah.
Yes.
Yes, sir.
Yes. So how much we are going to get this distance and this distance?
2D plus D.
Sure. Answer is
Yes.
3D. Answer is 3D.
Sir. So that distance is 2D plus this D.
This D, and this D. 2D.
Guess is like I'm getting top part 2D and center part D.
Now I'll explain
But
to
then
you.
that still leaves.
Leave it. I'll explain it to you. The problem with this question is now we are not given this height. I'm telling you, just in case, don't worry about it. This is not given. This height is not given, right, bacha? Hai na? Yeah. So this is X, unknown. We don't know. But look at the options. Option is either 3D, 2D, D. So can you conclude, sir, whatever be the X, answer is going to come 3D or 2D or D or D by 2. Are you sure now? Huh? That means what examiner is trying to tell you, that this distance is independent of X. Do you agree with me?
Yes,
sir.
Because answer is not given in terms of X, that means the answer is independent of X. So you can
sir.
choose whatever you want to choose X according to your convenience. So I am being very convenient and I will choose X is equal to D by 2. So that this is just half of it. And if it is D by 2, it's very easy to prove this is equal to D and this is equal to D. Does that make sense? Similar triangle.
Yeah.
Yeah. So what I'm telling you, X is not given, but answer is constant. So answer is independent of X. So whatever X you want according to your convenience of mathematics, choose it. So choose X is equal to D by 2, sorry. So if it is D by 2 and this is L, so D by L is the ratio, and this is D and this is total 3L. We don't know, so we can easily find this D. Yeah. Yes, so this comes D, this will also come D, and this is D. So the total is D plus D plus D. So take X as D by 2, bacha. D plus D by T is 3D. Is that fine?
Yes, sir.
Sir, can you
Yes,
tell again
sir.
how D by 2 helps?
Huh? Come again.
Can you tell again why we are taking D by 2?
Take it. I mean, take it is D by 2 is very easy. You are exactly in between the mirror. That's why, and it will make mathematics easier for you. Geometry easier. Why? Why? You know that. Let me show you. Why? Because this is total is the mirror is D, na? Yeah, D. I am saying you are here. You are supposing it here. The particle is here. This is the particle, and the image is formed here. This is L. This is L. Fine. And this is total distance. Object is at 12. Yeah, 12. Now listen. What we have to find is this, bacha. Listen to me carefully. Yeah. We need to find this thing. So we are going to apply the triangle method, triangle formula. Look at this theta, right? So this angle is theta, this angle is theta. So tan theta here should be equal to tan theta here. What is tan theta here, bacha? Y perpendicular by base. How much is base, bacha? 2D, right? Yes or no? This thing.
2L.
2L, sorry, my mistake. Thank you for that. 2L. Let's make it 2L. Fine. And what is tan theta here? This is D by 2 and this is L. So tan theta here in this triangle, a smaller triangle, D by 2 and L. So what happens? 2 cancel, LL cancel, Y is equal to D. It's very easy for you to prove that this distance is equal to D and this distance is also D if you suppose X as D by 2. Otherwise,
Yes,
you
sir.
can suppose D by 4 also, but it will become complicated. Answer will be same because you see option is independent of X. Fine, bacho.
Yes, sir.
Chalo. I think
So I assumed X as 0, so it will be 2D, right?
not a problem. Then you will get this distance as 2D. Got
Then
it?
the down one becomes 0.
Yes, down one will become 0 and you will get the answer.
That's what even I was getting 2D over there. For that.
That's good. That's really cool. Which of the following gives the monochromatic light? Sodium lamp, mercury lamp, spark
Is
lamp.
this
all of
term
them.
1 level question? Is this
No,
question?
not at all, not at all, not at all. It's JEE last year question. I'll tell you the exact date, 2012, and it was asked in 2016 also. It's not your level completely. It's JEE level, not a school level. Don't worry about it. Never will come in a school exam. Okay. Which of the following gives monochromatic light? Sodium lamp, mercury lamp, a spark lamp. I really don't know. Sodium lamp doesn't give monochromatic light. It gives two different types of light. Mercury lamp, a spark lamp. So
The internet said the answer is option D. I checked it now. And the internet said the
monochromatic light, sodium lamp.
Yes, so the internet said the answer is option D, all of the above.
All of the above,
But
na?
I'm not.
Because reason I'll tell you. Mercury is monochromatic, a spark lamp is monochromatic. I was getting confused with sodium because sodium gives actually bichromatic light. From sodium lamp, we get two different wavelengths of light, but both wavelengths lie in yellow color only. So I think they are talking about colors only, not wavelength. So one is better yellow, one is a kind of yellow. So that's why all of these correct.
Sir, what even is this?
Okay, so thank
Sir,
you.
what is this in the first place?
What is this meaning?
Like
Monochromatic
sodium
light.
No, sodium lamp.
It's a lamp where the light is coming from the sodium as a material. Got it?
Yeah.
Next question is the intensity of the scattered light varies with wavelength as lambda to the power 4, inversely proportional to the fourth power of the lambda. So if it
will be -4.
Yeah, if it is lambda to the power n, then you should put directly proportional, then you should put here n as -4. Rayleigh criteria. Yeah, I taught this in detail. Okay, now can we continue, guys? If you're done with this, magnification done. Fine. Now we asked some questions to the students. You guys can also answer me those questions. This was the question I asked, that look at this question. Two identical concave mirror, object is exactly in between the poles of the mirror. So if the image is formed on the object itself, then which of the following option is correct? Most of the students, they answer option B because they think that if object is at C, image is at C, but they fail to realize that option A is also correct. I want you all to look at the reason and tell me if you understand it. See the diagram also. First option B, D is equal to 4F, is quite common, because if you suppose that O is the common center for both mirror, then P2O from this side is 2F, P2O from this side is 2F, so total is 4F. That makes sound. Now if the object is at common focus, then you see from focus the ray is becomes parallel, and the parallel ray again passing through focus. So if object is at common focus, still you will get the image at focus only, at object only. So option A is also correct. This was a question also asked in JEE, but then now you may get this question everywhere else. What I'm telling you, if object is at focus, bacha, if suppose this O is the common focus, then see where is the image formed. Take the ray from object, this ray. So object is at focus, so ray is coming from focus. It hits the mirror. So ray coming from focus becomes parallel after reflection, so it becomes parallel. And parallel ray passes through focus after reflection, so it passes through focus. So finally, the rays converge at object only. So image is formed at object only. Yeah. So this 2F is also true. P2O is focal length, P2O focal length. So total is 2F. So both options are correct. Now we will move to the next part, refraction of light. What is refraction of light? Can anyone tell me quickly? What is refraction of light? Speak up if you have.
Bending of light when it moves from one medium to another.
Light moves from one medium to another.
This is a major misconception. Bending of light is not refraction. No book says bending of light is refraction. There are few local authors, they say bending is refraction, but it's not. Reason, I gave you this reason. If light hits water surface perpendicularly like this, it goes without bending. Is it not refraction? Every book says it's a refraction. So what we understand from here, in fact, if you read NCERT, due to refraction, light bends. Bending
It's opposite.
It's the change of speed of light.
the process of change in speed of light when light goes from one medium to another medium. This process is called bending. So bending is not the criteria for refraction. In fact, bending is due to refraction, due to the change in the speed of light. I hope you guys got it, right? Fine?
Yes, sir.
But then,
Yes, sir.
but
Yeah.
then indirectly the speed of the light changes. That's why it bends, right?
But
No,
sir,
it bends. That's why the speed of light changes.
nah, it's not that way. Speed of light changes, that's why it bends. Bending is due to refraction. And what is refraction? It's the process of change in speed of light. There is no bending when light hits perpendicular to the water surface. Will you not call it refraction? Tell me.
Yes.
Yeah, you will. So this is what I'm telling you. In fact, there are good authors like H.C. Verma. He got recently Padma Shri Award, right? H.C. Verma sir has discussed this thing on his channel, YouTube channel. And before him, I remember on my channel, that bending is not the refraction. Bending is actually due to the refraction. There are many misconceptions many teachers have. You know, twinkling of a star you might have read. Yeah, twinkling of stars.
Yes, sir.
Yes.
Yes, sir.
Yes,
Guys,
sir.
guys, what is the reason for the twinkling of stars? Tell me.
The atmospheric
Sir,
refraction.
atmospheric refraction.
Can you explain to me why?
So variation at an
The
atmospheric
changing
density.
density of the atmosphere.
Is it due to continuous shift in the apparent position of the stars?
No, sir.
So what?
Stars
What is
are not. Because the Earth's atmosphere has various densities in each level. So I think that's why.
now let me explain. If you see, I have seen this. Actually, you know, for us, do we see the actual position or a little bit higher position?
Little bit higher.
Little bit higher.
Yes, for us, apparent
little bit.
position is higher than actual position. And that is also due to atmospheric refraction. So continuously, there is a shifting in the apparent position for us. Is this the reason for the fluctuation or the twinkling of the stars?
It's because it's so far away that we actually tend to notice the fluctuation, unlike planets. It should also happen for planets, but it's just too big to notice the fluctuation.
Acha, next, I'll tell you, this is again a misconception. Many teachers on YouTube also, in fact, they are teaching also some teachers that twinkling is because of the continuous change in the apparent position of a stars. It seems to us as fluctuating. Wrong answer. I'll discuss that immediately. Second, how many of you think that total internal reflection is involved in the formation of the rainbow? Honestly, you guys must have been taught this way also.
No, sir.
Already discussed in our batch.
I think I discussed it or not? Did I?
Not
No,
just
no.
Sir, could you discuss it again?
Sir, can you explain, sir?
internal reflection.
Yes, it's simply internal reflection. Yes, Fatma, it's not total internal reflection. It's simply internal reflection. You guys have been asked question in exam also. One of the students clicked the question paper, exam paper question, and he showed to me that, sir, look, even in exam, the correct option was total internal reflection. I said, there are misconceptions among the people and they just copy paste everywhere. But its rainbow is not formed by total internal reflection. The biggest reason for that, if it is total internal reflection inside the water drop, then the ray will never come out of the drop. Then how will you see the rainbow? Secondly, if it was total internal reflection, then the brightness of the primary and secondary rainbow should be same. But you know, primary rainbow is much brighter as compared to the secondary rainbow. Yeah, Rachit, that's what I'm saying. People are, you know, just in fact, I discussed it first and then Vermaji discussed on his channel. I discussed this thing first on my channel, that rainbow has nothing to do with total internal reflection. Then few days back, Vermaji has also discussed the same thing.
Even in NCERT, it's given. Internal reflection, not total.
Yes, even
Sir,
in
NCERT
NCERT,
says internal reflection.
internal reflection. Yes, exactly. Okay, let's move on. What is the twinkling? Actual twinkling is the fluctuation in the brightness of the star. And you know what happens right now? Thousands of rays coming into our eyes from that star. But because the atmospheric condition is not same, it keeps changing. The conditions, the temperature, pressure keeps fluctuating. So the next moment, the very next moment, the number of rays entering our eyes may not be 1,000, it may be 1,100, or it may be 900. So there is a significant loss of the number of rays reaching our eyes. So number of rays reaching our eyes keep fluctuating. So that's how it gives an impact of fluctuating in the brightness of the star, which we call twinkling, because twinkling is basically fluctuation, the continuous fluctuation in the brightness of the star. Rachit, I'm completely disappointed with this. I really don't know, but if it is internal reflection in the option, click that. If there is no option like internal reflection, then you have to get the marks. Go with total internal reflection. Fine. Now, refractive index. What is refractive index? It is the property. Every medium has some properties. Yes, density is a property. Density decides how much would be the mass of a particular object in a unit volume. So conductivity is a property which decides the electricity passing through the medium. So a medium has a lot of different properties, each property responsible for something. Refractive index is again a property of the medium, and this property will decide how much would be the speed of light in particular medium. Does that make sense? Mathematically, how do we measure this property? Refractive index of any medium is equal to C by V. N is equal to C by V, where C is the speed of light in vacuum, 3 into 10 to the power 8 meter per second, and V is the speed of light in the medium for which you are defining the refractive index. For example, if you want to measure the refractive index of kerosene, if you are finding N of the kerosene, you must take V in the kerosene only. C is fixed, 3 into 10 to the power 8 meter per second. So mathematical definition is refractive index is the ratio of C by V. Both are speed, so it has no unit. That's it. Higher the refractive index, less is the speed of light in that medium. It's quite clear, yeah? So maximum refractive index in the NCERT table is for diamond. So minimum is the speed of light in the diamond. Fine, guys. There are certain questions. Then laws of refraction. When light goes from denser to rarer medium, it goes away from the normal. When it goes rarer to denser, it bends towards the normal. Everybody knows that. Yeah, tell me.
Yes, sir.
What is the Snell's law? What is the Snell's law? What does Snell's law tells us?
The sin A by sin R is equal to refractive.
Yes. When look, you can do this experiment. Take the laser light, increase the angle of incidence from I to I1. And you can move the laser light like this to increase the angle of incidence. You will find that angle of refraction also increases. I increases, R increases. But I by R is not constant. Yes, keep in mind, what is constant is sine of I divided by sine of R is constant. Is that clear?
Yes, sir.
Sine of I divided by sine of R is constant. Our class was only for 1 hour, guys.
Yes, sir.
Oh my God, we got few minutes only. Okay, let's continue with that. So sine I by sine R is constant, and this law tells us that if you increase the angle of incidence, angle of refraction will also increase. And this Snell's law only tells us that if light is going from denser to rarer, it will bend away from the normal, but if it is rarer to denser, it will bend towards the normal. That's fine. Moving on, this was the question I asked to many students, that angle of incidence in air is 60 degrees. Find the angle of refraction in the glass where the refractive index is √3. So you just use the Snell's law. Just look at this. Snell's law has been used, and you solve this. Sine I by sine R is equal to N2 by N1. N2 is the refractive index of the second medium, and N1 is the refractive index of the first medium. Yes, Divya, correct. So when you solve it, you will get sine R as 1 by 2. That means R is equal to 30 degree. I'm not going into that explanation, right? You guys already know that. And this was the another question asked. And this was Singapore International Olympiad question. I asked every student that there is an air bubble formed inside water, and this ray was given, bacha, this incident ray was given, and you were asked to draw the subsequent rays inside the bubble and outside the bubble. Will you believe me, most of the student, they give me this explanation this way, but it is wrong. You please check it. Why? Check it. Air bubble means what is inside the bubble? Bubble is basically air. Water is denser medium here. This is the denser medium. So here the light is going from denser to rarer, so it will bend away from the normal. That's why it's bend away. This is the normal. And then it is going from air to water. That means rarer to denser, it bends towards the normal. So this is how the ray goes. And I hope you guys understood it, bacho. Is it okay? Fine?
Yes, sir.
Yes, sir.
Chalo, great. So talking about, I asked a question to everyone that if you buy some material from the market, obviously for your lab, school lab, refractive index is given. So when the refractive index of glass is given 1.5, I'm asking you a question. Do you think that a glass which shows refractive index 1.5, is it 1.5 for all the colors of light, for all 7 colors, or refractive index of, yeah, tell me.
It varies.
So what is 1.5 when it says 1.5? And you are saying it is different for different colors?
So varies according to the wavelength.
Yes, so what is this 1.5?
It's for white light.
It's not for
It's
white
of
light.
yellow color.
Yeah, it's not for white light. It's basically, listen, you have a glass, listen, you have a glass, you have refractive index different for different color. Violet, different refractive index, maybe 1.51 for violet, maybe 1.48 for indigo, yellow, orange, green, red, all 7 colors. If you take the average, that average is mentioned 1.5. And interestingly, the average refractive index is close to the refractive index of yellow color, because of the reason yellow is somewhere the average of all. Do you understand it? Yeah.
Yes.
What is 1.5? Sir, average, and average is close to the refractive index of yellow. Keep in mind. Checkpoint. And who said that the refractive index of different material is different, of same material but different color is different? Cauchy was the scientist who said that. Who was the scientist? Cauchy. And Cauchy says refractive index of a medium is inversely proportional to the wavelength. See here how it depends on wavelength. Inverse relation. Higher refractive index, higher wavelength, less refractive index. Okay, that means red has maximum refractive index, so it has minimum. Yes, red has maximum wavelength, so it has minimum refractive index. Violet has minimum wavelength, so it has maximum refractive index. Guys, listen, more refractive index means bending will be more. So I want your attention here. Look carefully. Can anyone tell me, I hit the pure white light, it's going from water to air. Why violet bends max? Why red bends least? Can you tell me?
Violet has most refractive index, whereas
Yes.
red has least.
Yeah, red has minimum refractive index, so red bends least, violet bends most. Yes. How Cauchy derived that principle? It's not part of that discussion now.
It's related to wavelength.
Yeah,
Yes.
it's simply, did you just know that? How that derivation come? We don't have to know about it, okay? Yes.
Yes.
Yeah, though there is a distribution. I have done that derivation in my master, okay? By the way, coming to refractive index, refraction through the glass slab. And these are the points I discussed. You know, incident ray and emergent ray, they are parallel to each other, and the separation between incident ray and emergent ray is called lateral displacement and lateral shift. On what factors this lateral displacement depends? Number one, yeah, thickness. If there is more thickness, it may come down and then it will go out. So more lateral displacement. Similarly, it depends on the refractive index of the slab. More refractive index, more bending, and more would be the lateral displacement. These are the points you should consider, okay?
But,
Yes, guys.
so if it is a diamond slab, it will refract It will have more lateral displacement.
If it is diamond, right?
Yeah.
Yes, in diamond, the lateral, it's not lateral displacement there, but there is something we call deviation. We define deviation there because incident ray and emergent rays are not parallel there in case of diamond. Fine.
Okay.
Yeah. Okay, guys, I think we are done. Another batch has joined and I'm getting the beep for the next class. So done so much for today's. I mean, you guys can revise. The link has already been shared with you for this file. Okay. Yeah, that the note has already been shared with you guys. Yeah, tell me.
So like, what's the graph of incident and deviation?
In case of Prism, na?
So there's a question like that.
Yeah. I discussed that graph. Let me show you quickly. So somewhere in detail, Prism has been discussed. Yes, yeah. This is the graph, guys. This is the graph, the deviation by the prism and the angle of incidence. This is the graph. So I discussed in detail. Try to get these notes. If you guys don't have access to these notes, put in the support, put the mail or message to the support team. They will immediately share with you. Okay, guys. I don't have time. Otherwise, I would share with you guys. I have the batch waiting. Yeah. So if you guys can get it, please do that. Talk to the support team. Ask this page especially. Look, this file Chandra SP105. Tutor name Shahab sir. Chandra SP105. Ask him to share it, okay? And I will also, put the message and he will definitely share in the group. But if you guys ask from your end, you will get it as quick as possible. Fine, guys?
Yes.
Okay, then take care, bacho. See you all in the next class. Thank you.
sir.
Thank you so much. Take care. Bye, bacho.
Bye, sir.
Thank you so much. Take care.
Thanks so much, sir.
Thank you.